Okay, so I was asked about how to take the derivative when dealing with radicals. So here's just a quick video to sort of help you see some tricks on how to do this. Okay, so first off, when we see an equation like f of x equals the cubic root of x to the 5, let's start by turning this into an exponent. So I'm going to turn this into f of x equals x to the 5 over 3. Oops. X to the 5 over 3. Okay, so that's how it works. Is it's always the cubic root part, or the part that goes in the actual radical is your denominator, and the part that has the exponent on it, so the power on the actual variable we're looking at, it's going to be the numerator in your exponent. So the cubic part, the part inside the radical, becomes the denominator. The power becomes the part of the numerator. Now we're ready to take the derivative. So I'm taking the derivative here, right, f prime x. So we always swing the exponent in front. So that's going to be 5 over 3. Now we're going to go x to the 5 over 3 minus 1. Right? And 1 is just 3 over 3. So what we have here is 5 over 3 minus 3 over 3, which becomes 2 over 3. So I'm just going to repeat that, and this exponent here just becomes the 2 over 3. And then if we wanted to, we could write this part here, the exponent, in radical form. So I'm just going to put this on here to the x squared to the cubic root. And that's the same thing. So unless a question specifies, either form is usually okay, unless a question specifies that you need to leave it as radical or put it in exponent form. So next, let's try to look at more of a composite function here. So with this one here, I'm going to start, as with the last one, by putting it into exponent form. And if there's nothing in the radical, just assume it's a 2. So this is to the 1 over 2. Okay, now we're ready to take the derivative. So I'm bringing the exponent in front. So I swung that 1/2 in front. Now I'm going to take the derivative, or now I have to subtract 1 from the numerator. Sorry, from the exponent. So it's 1 over 2 minus 1. And then lastly, we got to take the derivative of what's inside the bracket. The derivative of 4x squared. Sorry, the derivative of 2x squared is 4x. So to sum up what I just did here, I brought the exponent in front. So I got the 1/2 in front. Then I leave the bracket as is. Then I'm going to subtract 1 from the exponent. And then I take the derivative of what's inside the bracket. Okay, now 1/2 minus 1 is just negative 1/2, right? Because it's 1/2 minus 2 over 2, which then becomes the negative 1/2. And then if I want to, I can bring that 4x, I'll swing it in front and just put it up here, like so. Okay, so what I can do here is I can make this a positive exponent. I can make this a positive exponent by putting it in the denominator part. And I can also clean this up. I'll do it in 2 steps, so just in case you're unsure what I'm talking about. So I will, first off, I'll just turn this into 2x, right? Because 4x over 2 is just 2x. Okay, then I'm going to swing this part underneath here. This is all sort of more of the simplification part. Okay, and then that exponent becomes positive. So all I did here was I just brought the, I made the exponent positive by bringing it underneath. And then lastly, if I want to, I can put it back in radical form, like so. Like so. And then we're done. So you can kind of see the steps to how we did that. We started off with the function in radical form. I put it in exponential form. Then I took the derivative. I brought the 1/2 in front. I subtracted 1 from the exponent. Then I took the derivative of what's inside. Then I simplified the 4x over 2 to make it 2x. Then I made this exponent here positive by swinging it underneath. Then I turned this rational, or this, I guess we could say, fraction of an exponent into a radical by taking the square root, and then we're done. All right, hope this helped.